Alright, 1a, summation notation. Plus minus, so there's the alternating component. X minus 3 to the third, to the second, to the first, and here we have x minus 3 to the 0. So there will always be an x minus 3 factor, and our lower index will be n starting at 0. Finally, we have the denominator for 3, 2, and 1. So if n is starting at 0, the denominator will be n plus 1. And there's 1a. Alright, how about 1b? Well, it's not a geometric series, therefore there's only one thing to do. By the ratio test, our series converges only if this limit is less than 1. So let's find out the x values for which this is true, and those x values will give us the interval of convergence and the radius of convergence. So here's the n plus 1th term, and then divided by the nth term, which is multiplied by the reciprocal of the nth term. Here we rearrange a little bit. Now, as n approaches infinity, this quotient approaches 1. And we can simplify x minus 3 to the power of n plus 1 divided by the same base to the power of n. That's just equal to x minus 3. So as n approaches infinity, we simplify this to just x minus 3. It's just equal to x minus 3. When the distance away from 0 is less than 1, that looks like this. Therefore, those values are representing x minus 3's distance away from 0. So x minus 3 is between -1 and 1. And since x is between 2 and 4, from the center to the edge is the radius. From the center to the edge of the radius of convergence is 1. And for the interval of convergence, well, that goes from 2 to 4. But as for the endpoints, we'll have to actually check when x equals 2, does this series converge? And when x is equal to 4, does this series converge? Well, when x is equal to 2, the left endpoint, 2 minus 3 is -1. And then our series simplifies to -1 raised to the power of n plus n, or 2n. That means the power is always even, which means our numerator is always positive. So this series is essentially a series which we can see clearly with comparison to the harmonic series will diverge. So 2 is not included in our interval of convergence. What about 4? When x is equal to 4, this green expression is 4 minus 3, which is 1 to the n. So that's just like multiplying by 1, which means we're left with -1 to the n power. So this series will be alternating. That wasn't true when x was 2. And with this alternating series, it's not the alternating harmonic, but like the alternating harmonic, it will converge. And therefore, our series does converge when x is 4. And so our endpoint on the right will be included. And there's our interval of convergence for number 1.